Question one. Who has the highest boiling point and how we figure it out? All right, how'd you come up with nickel?
So nickel and sublevel has the most section.
All right, so the first thing I would have done, based on what Nada said, is I'd have gone through and figured out where they are. So nickel is where? D block, and K is? And sodium, and chlorine, and fluorine, and aluminum, and neon. All right, so based on that, in group 13, we also know it's the P block, right? For this metal. So when we look at this, we know the highest boiling point is the D block, because D is greater than P, is greater than group 2, which is greater than group 1. So that's why we said nickel. Is everybody okay with why we picked nickel there? All right, so most reactive metal. Which group is the most reactive? Group 1. So we have how many group 1? 2. So what happened is we go down the group. More reactive. So that's why we picked K. Everybody okay with that one? All right. Most reactive non-metal. Which group is most reactive non-metal? 17. So group 17 is more reactive than group 16, which is more reactive than group 15. So when we look at those choices, group 17 is what you said, which is correct. But how many group 17s do I have? I have 2. So what's the rule for group 17? Down or up? Up. So who's higher up in group 17? Fluorine is the right answer. All right. And number 4, who is the least reactive metal? All right. Notice I said metal. So we only have to pick from metal. So I can't pick neon, fluorine, or chlorine. So I'm looking at aluminum, sodium, potassium, and nickel. All right. So we're looking at the same trend that we had here. Okay. This was what? I know it's group 1 thing. It says you wrong. Is it most reactive or least reactive? It's most reactive, right? Group 1 is more reactive than group 2, is more reactive than P, is more reactive than D. So group 1 was the most reactive, D was the least reactive. And I'm asking who's the least reactive, right? So it would be a D block. So who's in the D block? Nickel. Remember, boiling point and reactivity are what? They're opposites of each other. You can say inverse, nothing wrong with that, but they're opposites of each other. Okay? Which element is the least reactive? Now, tell me what the difference between 4 and 5 are in the way I worded the question. It could be anybody. I didn't say it had to be a metal this time. So, which element is the least reactive? Neon. All right. There it should be neon, because what do we know about neon? It already has 8. All right. It's a noble gas. It's perfectly content with its 8 electrons in the outer shell. All right. And which element has the highest density? It'd be nickel, because the D block is like boiling point. Same trend. D is greater than P, is greater than group 2, greater than group 1. Question. So number 4, what? Nickel. D block.
I don't know what the answer. I don't know.
All right. In the practice, I want you to do this. Because it's going to take over here. Okay. Probably, yes. And Victoria. Given the way Victoria's hacking back there, I'm not going to take my chance. Not that I don't love you. Paper's coming your way. Yeah. Huh? Where did you go? Oh no! I'm not with you. He's like the best teacher out of the whole day.
Oh yeah, definitely. You come up with your name.
Yeah. All right. I have to learn about it. Now, if you will, try to answer those 8 questions real quick. All right. They're very much like what you have in front of you. And see if you can do it by yourself without help. This will be very similar to structure test. Yeah, but we've got 4 more friends to go. Look who's there.
What's that? Chocolate milk? Yeah.
Orange chocolate milk. I have homework.
Come on.
Yeah. You have it for real? No,
I don't remember. If I did it.
well, check.
Well, you don't know the party.
Yeah. Hey, that's something.
You there 2 quiz grades. Let's hope so. You know, you did have a decent bus ride yesterday.
Yeah.
I can't do homework like on the road. I don't know.
Yeah,
I tried it before, but I can't do it. I can't concentrate.
You either have it now in mid grade or you got it in the senior. You want that. You don't get the time to talk. You now you get to do that.
No, it's my home.
What do we do? All right, find me some answers. Cool. What was good practice? Yep. Whoopsie. CS is in group 1, yeah. CA is group 2.
Three hours. No. Oh, wait.
How many of us are still working? Okay, I got one or two hands.
Yeah, it's like,
I'm not. Oh, I didn't see that. Yeah, do I get that also going up in my?
Really small, I lost my glasses, but it's not.
Like, oh, what is it like on the page? Oh, you know, go back to. Oh, yeah, but I hated those. He's like, you know,
Oh, yeah, I really, the part of that.
I thought it's that. It is DJ. What? Oh my God. I like that, your second after the 30 minutes. The actual battle scene. It was very well. It was very interesting.
Never mind.
No, I'm going to order it. They like woke up and kind of safety, safety the rescue, like, you know, they got a table, but they don't, not, what kind of, what they have on two monitors. What's the one they do the other day? Oh, yeah, we don't make it. I know he's not, how is there other abilities that was important? And after, like you said, no, okay. Okay. Well, we need to get that. Like, I've never had like after work. But yeah, it's just, the thing is, my cousin's brother was the only one that you think, but that's it. I hate everything. I love the noise. We get so much time. Turkey burger, I've had it at a college school.
All right, let's look at what you came up with. So number one, which metal is the most reactive? Why did you pick CF?
Because it's the lowest.
Group one. It's in group one. And how many elements are in group one?
Two.
Two. And where is it in group one? The second. Is it the bottom? Okay. So when you look at the element choices that you had there, I pull up a periodic table real quick. I don't think you have it anymore. Get rid of it.
I want to put it.
Oh my God. I ain't getting Southern lunch or chicken wings. I'm getting breakfast food. I ain't getting.
Oh, yeah. You probably open it all.
Alright. So, when you look at where lithium is, and you look at where cesium is, who's further or closest to the bottom? Cesium. Everybody okay with that rule? Alright, so then I'm going to have to go over down the shoulder roll. Alright, and number two, which non-metal is most reactive? First of all, when you read that question, who should you throw out of the question? Lead. Why should lead be thrown out of the question? It's a metal, okay? So when you look at the other three answers of chlorine, nitrogen, and oxygen, who's going to be the most reactive? Why are you going to pick chlorine? It's in group 17. Okay, group 17 is more reactive than the other three. All right, who has the largest density of those? Why'd you pick CR? Number three. Why'd you pick CR? It's in the D block. Okay? Who has the lowest boiling point? The number 4. All right, why'd you pick NA? All right, remember, D block is greater than P, is greater than group 2, is greater than group 1. This had the lowest boiling point, melting point, density, and it was the softest, right? Yes. So, when we looked at that, lowest boiling point would be NA because it's in group 1. Everybody okay with that? All right, 5, least reactive. Who's going to be the least reactive? Least reactive. And all I said was element, right? So I didn't specify metal or non-metal. The ones that don't do anything, which are the noble gases. So who's the noble gas? Ne. All right, highest melting point would be where? D block. Who's the D block? W. W. All right, when I say minus 3 ions.
Atomic number 74. Oh my God.
All right, so the highest melting point would be? It would be Pro-6. The highest melting point would be W, tungsten. It's actually, you know the old incandescent light bulbs? Anybody still have any old incandescent light bulbs in the house? That's the filament in old incandescent light bulbs that breaks. Tungsten.
It's like not fluorescent.
It's not fluorescent. They're the ones that get really hot when you touch them.
So it's that round one.
It's the round one. They're not the energy efficient ones. They get really hot. Well, they do produce ugly colors.
Okay.
And when you touch them, it gets really hot. Yeah. Could you like turn that light off or flip it over or put it somewhere so that every time you get a text message, it's not flashing in my face? Yes. Huh? Yes. Oh, that is a mercury compound.
Oh, that means wrong.
It doesn't mean wrong. What glow in the dark thing? Oh, that's a phosphor. That's a compound that phosphoresces. That's it's got fluorescent glow in the dark stuff.
I'm gonna do that.
Oh, really? Yeah. It has a phosphorus compound in it, but mercury probably not, because mercury is toxic. So you should be very careful when you're cleaning up the bulbs. Try very hard not to break those bulbs, Victoria. And try not to breathe up the dust from those bulbs too. Yeah, you should try very hard not to breathe up that dust. All right, number 7, the -3 ion. What is the -3 ion? Is the oxidation number. Daniela. The -3 ion is the oxidation number. And then the number 8, the elements with 3 outer shell electrons would be what? Al. Okay. I thought y'all said B.
Oh, yeah.
Okay. Maybe I didn't hear you, but I thought y'all said B.
What you said, number 8?
And that we said was Al. Okay. That's good. We've only done 2 trends, or 3, depending on how y'all number them. All right, so.
Because the elements in that group have 5.
So what now?
They have 5 out of
Yeah. Yeah. No, we're going to do something different tomorrow. We're going to do a periodic table puzzle. That counts as a lab grade. All right. I'm going to skip the Kahoot for a minute. We might come back to it. All right. We're going to talk about the 4 trends you have to know. All right. The atomic radius trend is the one you worked on last night with your homework. And then, I tried my best. The ionic radius goes right along with it, and it's pretty easy. And then, how did I do that? Not one minute.
So you created that order, right?
Yes, I am.
Ah!
All right, Alexa just stroked out over there. I'm grading both of them for correctness.
You get like a 25.
Oh, and by the way, if you got the answers to the element scavenger hunt online, there's 2 that are wrong. The answers are online, but there's 2 of them that are wrong.
Oh, yeah.
We'll even show you backwards. So you'll get those 2 wrong.
Which one's backwards?
Lithium and sodium.
I like text myself like to the search, but like I didn't find it.
Oh.
And now I'm terrified. I got.
Oh.
No,
Yes,
I'm
dude.
not saying I got 100, but now I'm like, now I'm
You only been in class for half hour. No. You ought to be able to hold it longer than that. Come on. All right. All right. Atomic radius. Now, if we're talking about atomic radius, all right, a lot of times we'll talk about radius being the size of an atom. But that's not its official definition. That's just basically what atomic radius is. You have some idea of what we're talking about for those of you who like simple definitions. Now, based on what we've talked about with the model of an atom, we know that there's a dense center called the nucleus, and we know there's basically an area of probability around an atom, right? Well, if there's an area of probability, can we measure exactly where the outside of an atom is if we don't know exactly where the outside of an atom ends? No. So, if we're not sure exactly where this outside edge is, we can't measure its distance from the nucleus to the outside edge, right? So, what scientists do is they bond 2 atoms together, and we have 2 sort of outside edges that we're not exactly sure, and they're supposed to be the same size, you know, but I can't actually draw 2 exact rings of outside edges. Now, if we know the distance between the 2 nuclei, we can measure the distance between the 2 nuclei. Now, think geometry class. What would that distance be called? Radius would only be from here to the outside edge.
Diameter, yeah.
There you go. Okay? So that would be called the diameter. So, think geometry class again. How would we get the radius?
They can have it.
Okay? They're going to divide it in half. Now, so how do we define atomic radius then, based on what we just wrote down? Atomic radius is defined as what? Okay. Half the distance between two identical nuclei. Okay, you have to use identical nuclei because if you had two different nuclei, would the distance, the radius be the same? No, and it has to be identical so you get the same radius. Okay, so you have to take half the distance between two identical nuclei. Two identical bonded nuclei. Bonded nuclei. By now, second quarter has given up. Not really. Give up what? You only do it every other day, so it's only really a fourth of the year. You got.
I know, but like we have 3, so it's always have just one today.
Oh. So every night you have homework. So you go home and you don't have homework. You're gonna have homework. My mother is the second quarter. It's like, I get a 9.
Oh, good God, stop
I'm
talking
thinking
about
55. All right, you need to raise your standards over there a little bit.
Well, you're my lowest grade, and it's freaking me out right now. So, like, all my grades are 100 right now. It's okay, my English is good. Yeah, my English grade is
My higher is
I know, no, I should feel bad, but I don't. Not even in the ballpark.
Okay, my grades are
Okay? Everybody caught up?
Yes.
All right, so we're going to talk what happens in a group and what happens in a period. Okay? Now, you have to know the trend and you have to know the reason why. So, let's just say, and I'm not going to write a bunch of these configurations. If we number the way you numbered, yes, it was the third trend. If we number the way Ethan was numbered, it's the fourth trend. You numbered 3 trends yesterday, so this will be your fourth trend. It's her third trend. I don't care which way is correct. Doesn't make any difference. I'm only writing 4, so stop panicking. It will suffice to just be 4.
brings that bad news.
Sorry. I don't mean to bring back bad news.
So,
Alright? This is all part of the atomic radius. You gotta know the group and computer screen. No, I think if I had those two squares down,
oh,
You should have.
yeah.
I think I would have. That was can't do that. That's it's what we got on the road in my life. Try to win the lottery.
Well,
Alright, so when you look at this, okay, we're talking about elements in a group, right? What can you tell me about the energy level in hydrogen? Okay? What's the energy level in lithium? highest energy level in sodium, and in potassium. So tell me what's happening to the energy level as we go down the group. Okay, so as we go down the group, energy level increases. So if I was to draw pictures of this, like one ring, two rings, three rings, four rings, right? So if the energy level is increasing, what can you tell me then about size? All right, so size or atomic radius increases as energy levels are added. Okay. And I think this is question 3. All right, so question 3, if you said atomic radius increases, there's 3 points. And if you gave me something about energy level or something about the reason why it was increasing, make sense about energy levels or rings or subshells or something being added, then you got all 5 points in that question.
I don't remember what I'm doing. I don't
That's
know.
number 3.
I don't remember.
So I was right.
Yeah, I only had that. No, that's. Oh, and I remember my club. I know I did it at the club, right? I don't know what.
I don't think I did a list. That's all.
I thought it was a thing of my own.
Now, the period tree. I need to go back? Good God, y'all need to write faster. We're never going to finish this. It's going to take us 2 hours today to do this break.
No, we got her. We got to do it.
I got things to grade. I do if I have to. Okay. Now, so in a period, we're just going to take period 2. I'm going to pick 4. So lithium has 1s2, 2s1. Carbon has 1s2, 2s2, 2p2. Oxygen has 1s2, 2s2, 2p4. Although my s's look like weird fish. And neon has 1s2, 2s2, 2p6. Okay?
Oh, that's nice. Well, that was what?
You can't put that up.
No.
What in the world?
All right, got up? Now, what can you tell me about the energy level here? He's wrong. Okay. So, the energy level stays the same. So, if the energy level is staying the same, okay, the energy level is staying the same. Is it getting bigger?
No.
Yes.
That's right. They're not getting bigger. Yeah. I told you Jeff it was full fun. All right, so what is changing? Okay, the electrons are changing, but the other important part are the protons. Lithium has 3, carbon has 6, oxygen has 8, neon has 10. Okay? So, the protons pull the electrons closer to the nucleus. Okay? The protons pull the electrons closer to the nucleus, shrinking the size of the atom. Think of the protons sort of as magnets. Doesn't actually work that way, but I'm just trying to give you a visual. Okay? So the protons sort of pull the electrons a little closer to them. Because this doesn't have as many protons, it can't pull them as tight. This has more protons, so it has more attraction, and it pulls the electrons closer to it, shrinking the size. Okay? So, in this one, as you go across size or radius, decreases.
Well, we started talking about ions, we got it wrong.
You started talking about what?
Ions, we got it wrong. I said there were more photons.
Not necessarily, I have 3 things. Not necessarily.
And that's because you didn't get any help, I will give you a little slack.
I completely, because I so, I just guessed, but I really didn't know, I was like, I don't know why.
The buttons are more than Yeah. That's not possible. Say what now? Then I'm getting old. Okay, you got it, Deshaun? All right, so for my visual piece. All right. So, what did we say happened as we go across? No, we did not. That's right. We said it decreased as we go across. What did we say happened as we go down? It increased. All right. So, based on that, looking at your periodic table, where is the biggest element on the periodic table? Forget the F block exists for the next rest of the day. All right, so we got FR and we got RN on the floor. So which one would be right, FR or RN? FR. FR over here, all right, is the biggest element on the periodic table. Okay, because as we go down, they get bigger. And as we go across, they get smaller. So RN will be a little smaller because it's over here. All right, who would be the absolute smallest element on the periodic table? HE. Way up here in the corner would be the smallest. Because as you go across, they get smaller. And as you go down, they get bigger. So it's way up here in the corner. As you go down, they get bigger. Down here is going to be the biggest. The way up here is going to be the absolute smallest. Okay? So, let's say we'll find the smallest or the biggest in these groupings. Pick one. okay? Or Josh on first. All right, so we're gonna find the largest in my group here. Atomic radius, yeah. All right, so in this picture, yes, if we need to label that, this is for atomic radius. And given we're going to do several of these tables today, that is for atomic radius. All right, let's do VA, CA, MG, SR. Number 2, let's do RB, CE, NB, and XE. And number 3, let's do AF, FD, FE, and TE. All right, given those 3 questions, find the element that is the largest in each question. So assume those are 3 test questions. The answers are A, B, C, D. Find the one that is the largest in each question, largest atomic radius. Given those choices. All right, done?
Oh,
Yeah. Yep. Wonderful. Yes, you're going to pick 1, 2, or 3.
I did all of
That's good. Let's go. One, two, three. No, not 1, 2, or. Did I say or?
Oh, 1, 2, and 3.
Oh.
I think what?
We're not. No.
Ooh, here, dude. Oh, okay.
She thinks you're great.
See, I didn't want to bother them, that's why I'm not saying that. Okay, we're gonna
All right, are you done? Yep. All right. So if you look at where the question from group 1 or number 1 came from, where did I put all those answers? They're all in the same group, right?
Yes.
So where would the largest radius be? At the bottom, right? So which element's at the bottom? VA. Okay. So if you look at where they're all at, MG's at the top, and then you got CA, Then you have SR, and then VA's down here, right? So if they're all in that row like this, who's at the bottom? VA. So that's why the answer should be VA in this particular answer choice. Everybody okay with that?
Yes.
All right, so if you look at number 2, where'd all those answer choices come from? No, they weren't all in different places. They were in the same one. They were all in the same period. They were in period 5. RB was over here, and then NB, and then TE, and then XE. They were all in the same period going this way, right? So, who would be the biggest if they were all in the same period like that? RB would be the biggest because they were all in the same period. Okay? Okay. Now, you see how I write them down that way? That's because I'm visual. You don't have to write them down that way. You can write them down any way you want to. You don't have to write them down. You can just look at them on the periodic table. This was a visual person. So if you actually saw my test answer keys, they're written down like that. 9 times out of 10, I have the arrows written down under them. Or I have increase, or in this case, because we're doing atomic radius, it says decrease, increase under them because I'm a visual learner and I've done this a long time. Okay? So that when I do an answer key, I don't jack up my answer key so that when I give the test papers back, Daniela doesn't go, Ms. Wall, are you sure that answers what that is? Okay? Because I will, or Tashon doesn't come up to me and go, you sure this is the right answer on this? Okay? By the way, did you get that answer right on the test?
I don't think so.
You want to know how many inner shell electrons gallium has? There's 28, by the way. 31 minus 3 is 28. All right, so these 3 are the only ones that are not in the same group in the same period. These I put in the square. So if you look at what they're at, where they're at, you got AS, and then SE was right beside it. And then I had TE right here. And then what else do I have? SB right there. All right, so what do we know happens as we go across? They decrease. So I know these are going to be smaller, right? Because they get smaller. Now, what happens as I go down? They increase. So that means this one has to be the biggest. Okay. Questions about that? Everybody okay with radius?
Yes.
All right, let's talk ionic radii. This would be the next trend. Alexa. All right, ionic radii. This is the next one, whatever number you have. So is it 4 for you, 5 for him? All right. An ion. What did we already define an ion as this semester? What? Well, Packers are looking better by the day. It has one.
Is that like carbon 14?
I know, all I do is like every time they get bigger,
Carbon 14's an isotope.
every time they get bigger, it goes.
It's like, it's part of the
Wait,
Every an element like gains or loses electrons in the top of
I was just.
so you know that let me get the wrong answer though.
It's an atom with a charge. Okay? Basically, it gains or loses an electron. Okay? That would be good. That would be good. That'd be the right answer. Okay? So, okay.
Oh my God.
Tell me. My husband told me if we ever won the lottery, I could have El Paso.
Wow. Your husband's so supportive of your outside.
So then you can have some. We can have some.
That's amazing.
I told him if he wanted enough money, we could have somebody take care of my alpacas for me. I could just go visit them. Alright, so what's the cation and the anion?
Oh, that's fine.
Okay, so which one's positive, which one's negative? Alright, we got some skills out there. Alright, so cation's positive and anion's negative. Now, which one loses electrons? We got some. Y'all were just lost on the definition of an ion. We're not in bad shape. See, it's just a definition of ion. We're alright. Alright. So, we want to talk about size. Since we're talking about radii, we just want to talk about some size. Okay? Now, if we were to talk about something like O versus O negative 2. Okay? Starting there. Who would be bigger? Why? Okay. Who's bigger? Because it gained electrons. Think of it as you gained weight. Or you lost weight. Okay? Everybody in the room had that experience. Alright? If you gain some pounds, you're bigger. So if you gain some electrons, you weigh more. You're bigger. If, let's say you sodium, and you got sodium ion here, alright? Alright, and you got this little +1 right there. What's that +1 mean? That's right. You lost weight, right? That means you lost electrons. That's right. That would tell us that one is lost. Because it lost electrons, you lost them. Does that make sense? Okay. That's correct. You can write that down on the next board instead of me shrinking this board, making it small. No, do any of those test corrections, you just don't play on that phone. You don't have to, it doesn't make any difference to me. I just ask. No migration. I mean, you won't have to deal with power tomorrow. I mean, all right, everybody got it? So, a cation is blank than its parent atom. Alright, so when we talk about generic statements or correlations, like Danielle said, alright, we can talk about cations and anions compared to its parent atom. Now, a cation is what we it's small, okay? It's the same less, okay? A cation will be smaller than its parent atom. So if I go back for just a second, okay? Na is the parent atom because there's no charge on it, right? This was the cation, and what did you say about its size? It's smaller. Does that make sense to everybody? Okay. Now, the second statement I wrote was about the anion. So this is the parent atom. That was the anion, and what did you say? It was bigger. That's where those two statements came from. So an anion is bigger than its parent atom. Everybody with me so far?
Yes.
Nobody lost?
Not yet.
Not yet. You couldn't get lost today. The worst part about this unit is just learning the tree. Not hard. Just tedious. Now, what if I said, I do too.
Let's do it.
Yeah, that's it.
Man, I had this one. Is that BA?
Yep.
I know.
Imagine that.
What?
And they got paid for it too. Not like.
No, I mean, no, I'm talking about what, oh, okay, that's up to my,
Hold on, where are you working at?
okay.
Okay.
Okay, so
You know what that food costs at Fujimoto?
Yes, no, but listen, no, listen. Okay, I understand that they don't want to, right? But when they ask for no oil, no butter, no soy sauce.
That's the whole.
And that's the whole point. It's the soy sauce.
Okay, now I need an envelope. Why would you go to Fujimoto?
That's what I was like, what in the world?
Oh, can you put,
I would agree with you on that.
I was so confused. I didn't get my boss.
Yeah, for all the-
I didn't get my boss. Right? And then I'm like,
So it's
Just
fine.
stick to the grill. What do you do? I mean, you just like scrape it off and it's gonna bond to the grill.
Yeah.
I said, what's that?
Okay.
You give it a fly to get it off.
You said I'm hot pot like
Exactly.
Okay. What kind of meat did they get?
You got chicken.
That's really sick. All right, so when you look at those four choices, how do we choose?
Don't look at
Based on the, yeah, because they're all in the same what? Group. Okay, so you're going to use the group, okay? Because they all have the same oxidation number. They're all in the same group. You fall back on the trends you already know from atomic rates. All right, so who would be the smallest? Yes. Okay, any issues with that? Now, lots of people ask me if I will vary the oxidation number. The answer is no. I could and extend this into what's called an isoelectronic series, but I'm throttling back and not adding that into the curriculum. Okay, it's an AP topic. I could, just not. Learning to scale back. All right, ionization energy. 2 trends left. So this is what's one now? 5, 6 for you. Okay, ionization energy. Okay, is energy needed to remove an electron from an atom. Okay? Now, you can remove more than one atom. Now, when I say an electron, I'm talking about how many? One. So sometimes we will say first ionization energy, and that is 1 electron. We can talk about second ionization energy, and that would be the second electron removed. Or we talk about third ionization energy, and that would be the third electron removed. Guys, I will probably not get crazy and go there, but depending on time, you might. All right, but you can always remove more than 1 electron. Doesn't have to be just 1. But when I say ionization energy, I'm talking about which one? I'm talking about the first one. When we just say ionization energy, we're talking about the first. If I want to say second or third, I have to specify second or third ionization energy. Thursday. Tuesday.
Oh, that's nice.
Technically,
That's like a Wednesday.
yeah, it's technically on Friday. Yeah, because today's Wednesday. Yeah. No, it's gonna be wrong. Yes, it will look very much like Yelp. Or the worksheet that we just did a little bit ago. Yes, it will look a lot like that. We're all hungry. We all don't want to be here. Hey, tell me the Black Widow story. The freaky matter.
Oh, okay. So I was gonna go that. So like one day I had an order come in, but the person didn't want butter, oil, or salt and pepper.
So how are you gonna cook it?
I can cook it.
Throw it on the grill.
Just do it on the grill. That's how you want it.
How did it turn out? How did it turn out? Not good.
But when are you going to put photos? You're not gonna get a box of
Right.
No butter, no sauce, no oil, no nothing.
Like, how would it cook up without? It was
I don't know.
really
I have no
dry.
idea.
Yeah, I thought it was dry.
That's like it sticks to the grill. Can you imagine?
Did you tell them this ain't Burger King? Don't get the way you want it.
It's not your way.
Yeah.
Over there by the little Walmart.
Oh, okay.
Little
Yeah.
Walmart. Big Walmart.
Yeah, the little Walmart. Big Walmart.
Little Dollar Tree too. They don't have anything at Dollar
Oh, really?
Big one.
Tree. I have to go.
Hey,
Hey,
where? That little house.
The But it's lovely, but it's really going away.
Okay, so I got it. I'm used to getting on the job.
Oh, it's good, huh?
Everybody else? But then not. No, like, you can feel it. There you go. So,
I think it's, I know how to talk.
All right. I've been sidetracked. No, you're fine. It's easy to do today. Where was I? Oh, yeah. I just extra. All right. So, group trend. No, we're on orientation. We got to talk about what happens when we go down the group.
Oh.
Just like we did the topic gradient. Now, I don't want to write all those electron configurations out, so can we skip that?
yeah.
Okay. So, I'm just going to draw pictures. Will that work this time?
Oh, yeah.
Yeah. I figured y'all might be.
This one.
Yeah.
You know, this one is from this one,
What?
that they are not supposed to go to that. So about that.
Somebody says, I'm pretty sure she wouldn't be okay with that one.
No, that's correct. Wait, what?
Technically, you can say it. It sounds really stupid, but you can say it, so that's what you want to do.
Okay,
Correct.
okay.
I know that. Instead of, well, that's a space.
Okay. All right then.
Oh, yeah, you would.
Okay. Four. Alright. So, what can you tell me about the outer shell electron in each of those pictures? Okay, that is very true. What else could you tell me?
They're in the outer shell. Outer shell.
They're in group one.
All right, they're all in group one. They all have one. They're all in the outermost shell, yes. I'm looking for something else.
They're all on the right side. Or left.
I could have drawn them on the other side. That is irrelevant. That's irrelevant. Yes, please. They are all going to lose one, yes.
Is this because?
Yeah. Okay. Okay. All right. The energy level is increasing, which is why I drew the pictures instead of writing the electron configuration. All right. The energy level is increasing, which means the electron in the outer shell is further from the what?
Nucleus.
That's right. It's further from the nucleus. So, is that electron held tightly to the nucleus? No. Okay? It is easier to lose the electron the farther away it is from the nucleus. Okay? The further that electron is from the nucleus, the easier away it is to lose. Okay? Sort of like if I took a field trip by myself with 4 periods, which has 12 people in it, odds are good I could keep up with 12 people. But if I took all 3 of my classes, which have about 60 people, can I keep up with 60 people by myself? Probably not. Odds are good I'm going to try really hard not to keep up with several people in 3rd period. Now, yes, exactly. So, given that, electrons are the same kind of way in the atom. The further they are from the nucleus, the less tightly they're held here by the nucleus, okay? Nucleus is here, the electron's out here, not held as tightly to the nucleus, okay? So it's easier to pluck it off. This electron, right here with the nucleus, whoops, nucleus is one way, held very tightly to the, whoops, move my head, okay? Electrons held very tightly to the nucleus, very hard to remove it because it's right there. This one's way out here, much easier to pull it off, okay? So as you go down, ionization energy decreases, okay? It's easier to take away from the farther away, further away from the top. Further away from the nucleus, I can't break it. Sort of like if we go on a field trip. There's 60 of us. I can't keep up. Way out there, I can't keep up with them. God.
Oh,
4 periods.
oh, they're here. Went live. I should have done those.
Alright, as you go down, the ionization energy decreases. Everybody got it?
Yes.
All right. So, period trends. Now, the nice thing about this is it's the exact same thing for ionization energy, or sorry, electronegativity, so we don't have to do the period and group trends for that one. No, we got to do electronegativity, but we don't have to do the period and group trends because it's the same. All right. So, well, the trend is the same, but there's a catch for that one. There's always a catch. I'm going to do this one this way. Instead of the electron configuration. Let's do it this way.
Oh, yeah.
Notice I drew it small. We don't need a lot of space.
Okay. Let's see if this y'all here got a hand wrong. That's all. Why do you do that?
Well,
You know, like at the bottom from like 6, 7, 8, you don't lift up one. You just go whoop, one, and it's not like that. See, look.
because it is down.
Yeah,
That's how they periodic table 2011.
but this one's thinking.
I know.
It's so angry. Or you don't want to take it. I love it. Yeah, I'm not. Similar third. Hey, what's up?
There, is that better?
Oh, yeah, yeah, fine.
Y'all been together since before I have huge questions. And I really don't understand biology very well. All right, so when you look at the periodic table, okay, what do we know? I hope y'all know more than you think. All right. Over here, we know it's easy to lose an electron, right? And over here, we know it's hard to lose an electron, right? So, we know that in group 1, these elements want to give up an electron. We know over here, they don't want to lose an electron, right?
Oh, yeah.
Yes. So, if these elements want to lose an electron, and these elements don't want to lose an electron, all right, because these want to lose and those don't want to lose, what's going to happen as we go across from left to right? What's going to happen to the ionization energy?
They want to increase.
It's going to increase. Ionization energy will increase. Okay? All right. So, ionization energy increases as you go across because you are closer to what?
Okay.
Closer to the octet this time. You're closer to an octet, and atoms don't want to lose electrons. Okay? Ionization energy goes up as you go across the periodic table because you're close to having an octet. It doesn't want to lose the electrons. You almost have 8. It doesn't want to give up any electrons. It's trying to gain electrons at that point. It certainly doesn't want to give any away. Anybody else hear that? Bro and Mario's phone. All right, we caught up? All right. It'll be the end of the quarter. All right, so for the visual picture. Let me not squeeze it in right there. Then when you got it, Shy. I'm sure you cannot go buy food. Y'all cannot leave and go buy food. I'm sure you would, no. I like my job most days.
They don't need to know. I mean, some people want to go by pizza. Yeah. Kids go by pizza. A teacher said.
Oh, yeah.
I don't know who, and like, no, we're not doing that like ever.
What?
Like, no.
Huh?
Are you there, Shy? Come on. Okay. All right. So for my visual people again.
Probably. You don't like that slide. Oh, I know.
All right. All right. This one is ionization energy. As you go across, what happens?
Increase.
An increase. And as you go down, it did what? All right. I want you to look at atomic radius. Tell me how they differ. That's from ionization energy. This one's ionization energy. And then I want you to look back at atomic radius. Tell me how they differ. They're opposite. They're opposites of each other.
Inversely
They're inverses. You can say either way. Okay? It's okay. It's okay. We know what you know. Now, does everybody see that? Atomic radius and ionization energy are opposites of each other. Sorry, you with us on that? Okay. Sorry, you with us on that? They said atomic radius and ionization energy are opposites of each other. So earlier when we drew atomic radius, you look back in your notes. I'm not going there either. Let's find out. Okay. I don't care if you find out. All right. Look at those two trends. Ionization energy increases as you go across, decreases as you go down. But atomic radius did what? Decreased as you got across and increased as you went down. Okay, this is already in our notes. That's what we just did. What can you tell me about these two? They're flip-flops. They're opposites of each other. Okay? So don't get those confused. You with me on that? Now, one of the ways that you can use this or as a study technique is, I don't know this one. I don't keep that one in my head. I keep this one in my head. Exactly. Okay? Because it confuses me to keep this many arrows running around in my head. So I know this one. I draw this one on my paper. I know this one is the what? It's the opposite. And so once I have this one on my paper, I just write this one down and draw the arrows flip-flop. Okay? Everybody with me on that? Now, the last one we have to do is electronegativity. Our last trend. And this one we will use in bonding until y'all are sick of it. It's a major focus in bonding. Okay? Electronegativity is defined as an atom attraction for electrons to itself in a bond. So, suppose we have a hydrogen bonded to a fluorine. These dots represent electrons. The question is, who pulls on the electron? That's what electronegativity measures. Think of electronegativity as like a tug of war. Okay?
What is the bigger one? More.
That's exactly right.
Yeah. The one of the biggest group always wins.
Exactly. That's exactly what electronegativity is. So if you ever watch tug of war at field day, electronegativity is a tug of war. Okay?
That ain't pitfall, though. Pitfall got serious.
Alright. So, knowing what we know, what do we know about chlorine? How many outer shell electrons does it have?
Wait, what?
7.
7. How do you know chlorine has 7 electrons in the outer shell?
Because it's in a.
Group 17.
It's beside the ocean.
It's in group 17, right? So, how many outer shell electrons does hydrogen have? Alright, so what do we know hydrogen wants to do?
Lose one.
Oh, yeah, lose one.
Lose one.
Alright,
7.
so hydrogen wants to lose. Alright, the other one wants to gain. Alright, so, without talking about bonding at the moment, we'll get to bonding. Alright, so remember, this is tug of war. Those are electrons. The electrons are ropes. They're tugging over. Who's got more pull pulling on the electrons back and forth? Chlorine. Okay? So, chlorine is going to pull those electrons its way because it wants the electrons more. So, chlorine has a higher electronegativity. And capital E, capital N is the abbreviation, by the way. Here, I'll write that up there. Capital E, capital N, because that's how we abbreviate it, so we don't have to keep writing down electronegativity.
I understand why you say it. I understand what you say.
Because it's a lot to remember.
It's a lot to remember. It's tedious.
I got this. No, but I believe in us.
I do too. Y'all are very bright. You're very
Yeah,
capable.
we're very bright.
What? At the end of first quarter, your grades are not moving. We have so many grades at that point.
Yeah, no, that's what I was saying. So that's why. It wouldn't affect that, you know.
It's not, even at the end of this quarter, by the time we hit January, we have so many grades, nothing is moving.
Girl, I like to say a great comes back.
Oh, yeah, I remember with that was your. Yeah, you got that.
I was like a 9.
Oh, by next Tuesday. So hopefully by next Tuesday we know. Tuesday, because next Tuesday they have to send it off.
Oh, I forgot they have to have it.
And then they pick the 3
All right, we there? All right, so what's the trend as we go across the table then?
It will increase.
All right, do you remember what I said for ionization energy was the same? So it will increase as we go across. It will decrease as we go down. But if you were listening a minute ago, I said there was a glitch, right? Here's the glitch. The glitch is the noble gases.
Oh, that's because they already have them. They don't want to.
And they don't form compounds. So He, Ne, and Ar, okay, have no electronegativity. Okay? They've actually formed compounds, so they have one that's measured. Fluorine is the highest. F is 4.0. So you need to remember that when you're doing electronegativity, that fluorine is the highest, not the noble gases. Okay? That's the glitch to electronegativity. The reasons are the same. Nothing about the reasons change, except that noble gases don't have an electronegativity.